Hello everyone. So this is a continuity of the last video. So here we will see what went wrong. So we have seen when the Arduino's code program come to line number 16, t value is 2500. Okay, if you don't understand this, go watch the last video very carefully and come here. Okay, I am assuming that you have watched the last video, you are coming here as a continuity, so that therefore you will understand this. Otherwise you will not understand this. Okay, assuming so, I am telling now 16, line number 16, t value is 2500. Okay, now the next for loop iteration. Okay, wait. Okay, when the t value is now 2500 here, what are the LEDs on? LED number 3 is on, LED number 4 is on, LED number 5 is on, 6 is on, 7 is on. All the 5 LEDs will be on state, switched on. Yes or no? Yes. Fine. Now, this for loop is going to happen. Okay, this is going to switch off all the LEDs at the same time now. Okay, first iteration, this LED will be gone. This LED, next iteration, this LED, next iteration, this one, next iteration, this one. Everything will go off. Then once everything is go off, this will become false because I value will be made 8. Okay, because line number 7 LED is pin number 7 LED is switched on. Then I become 8. This will be breaking the for loop and will come to the line number 20. Okay, is there any manual delay? No. So this line to line movement will happen in no time, 0 time, isn't it? Yes. Every iteration will happen in 0 time, isn't it? Yes. So once the iteration is finished, we will immediately pass here. That also will happen in 0 time because no manual delay is given anywhere else. Here, no manual delay. So jumping out of the for loop also will be taking, from here until the end for loop finished and coming out here, everything will happen in 0 time. So the t value will still be 2500. Okay. Now see 3, 4, 5, 6, 7. Okay. All the LEDs should be what? Off. Nothing wrong. Okay. Still nothing wrong. Okay. All the LEDs now off. Okay. So this 3, it was made on. Okay, at a particular time. 4 made on, 5 made on, 6 made on, 7 made on. Okay, when the 7 made on, okay, then after 500 millisecond only we came here. After 7 as pin number 7 made on, then after 500 millisecond only we come to the line. Yes or no? Then we switched off everything together. Okay, so for all these LEDs are switched on and switched off state, there's a minimum of 500 millisecond delay time. We should accept that because last LED is switched on, then everything is switched off. There's a 500 millisecond delay. Okay, so other LEDs that were switched on at least 500 millisecond before each and everything, so they have more time delay for the on and off. Okay, so for the example, if you take pin number 6, for its on and off, there is 2 500 millisecond delays. That means 1 second delay if you calculate it. You understand? So there's we are saying switch it on and switch it off. For those two commands, between those two commands, we have minimum 500 millisecond delay for each and every LEDs. Minimum. Okay. For the last LED itself, we have 500. Other LEDs we have more. So for when you say command, we have minimum 500 millisecond delay for saying it, saying okay, switch on the LED, for giving the order, and for giving an order, switch off the LED. Between that, we have minimum 500 millisecond. We never gave the opposite orders at the same time. Okay, you understand that? If you otherwise you can calculate when you switch on the last LED. Okay, pin number 7. Okay, it was t is equal to 2000. Okay, I'm not sure, 2000 or something, right? Yes. Okay, t is equal to 2000 when you switch on the last LED, if you calculate. Okay, but here when we come here, or here switching it off everything together, t is equal to 2500. Or here, okay, we came here and we switch off everything hereafter, so 2500. So 2000 and 2500. There's 500 millisecond delay, at least 500 millisecond delay. So we didn't give the opposite orders at the same time. We gave a time delay. Okay. If we give the opposite orders at the same time to Arduino, it will get confused. But there's a time delay, right? 2000 and 2500. Between the last, only I'm considering this last LED. Okay. 2000 and 2500. We switched on here at the 2000. We switched off here at 2500 or here. Anything. Okay. So 500 millisecond delay is there. For other LEDs, more delay is there. Is that understandable to you? If you didn't understand, rewatch this video from beginning. Otherwise, you will not understand further. Okay. Now let's check. Okay. Right. We switched off all these LEDs at t is equal to 2500 at this time, because there's no time delay from here to here. No time delay. So we switched off everything at the same time. Now what will happen? Next void loop iteration is going to happen. Okay. So this is t is equal to 2500. So when we come here to this line, still it is to t is equal to 2500. Why? Because there is no manual delay. So when we come to this line, again t is equal to 2500. Again t is equal to 2500. And again we come to this int I. Now the new t is still 2500. Why? There is no manual delay. So moving one line to another line will take no time. So same time will be there like the previous line. Okay. Then again we start this for loop. Okay. Now also this t is, when we start it, t is 2500. Okay. Then we switched on LED number 3, first LED. For which LED we had the issue that didn't go switch off, right? We had the issue for the first LED, right? Pin number 3. Now we are switching it on. Okay, look at this, guys. So we switch on the pin number 3. Now what is the time? From this line, this was 2500. To this line, is there a gap? Is there a manual delay? No delays. So this is t is equal to 2500. When we switch on the pin number 3, t is equal to 2500. Now look at this. From the previous iteration of the void loop, when we switched off the pin number 3, t is equal to 2500. From the next iteration of the void loop, we switch on the pin number 3, still t is equal to 2500. So same time, t is equal to 2500, t is equal to 2500. Even though they are two different iterations, one after another, the time is same. Because no time is taken from moving from one line to another line unless there is a manual delay. At the same times, we have set the pin number 3 to switched off and to switched on. Here we say to switch off, here we say to switch on. See, digital write high and digital write low. So what is the issue? At the same times, very moment, at t is equal to 2500, I am saying Arduino, switch off the LED and switch on the LED. So now Arduino is confused. You understand this? That is why it couldn't switch it off. It kept it switch on. Okay, maybe from here or anywhere. It couldn't properly do what we said. It kept it switched on. It couldn't switch off. Because at the very moment we switch off, we switch it on. So it kept it switch on. You can think like that. At the very moment you switch off the LED, you switch on that particular LED again. At the same time. So you are saying at t is equal to 2500, switch off and switch on. So it cannot be possible, right? T is equal to 2500 now, switch off, switch on. So Arduino will take your same time, you are saying two different opposite arguments. What can I do? Opposite commands. That is why it didn't work as we expected and it stayed in switched on state because the time is same. Look at the next LEDs. Okay, now there's a delay, no? 500 millisecond delay. So this for loop is, first iteration is finishing. Now t is equal to 2000. Sorry, 3000 because there's a manual delay of 500 milliseconds because this delay is there. Okay, then we switch on the fourth LED, pin number 4, next LED. Yes or no? I is 4 now. At this time, what is the t value? T is equal to 3000 because t is equal to 3000, t is equal to 3000. So if you consider fourth LED, fourth pin, second LED, when it switched off from the previous iteration, t is equal to 2500. When it switched on from the next iteration, t is equal to 3000. So there's a 500 millisecond delay he gets, fourth LED. So he didn't have an issue. He switched, see, he went off and he went on. He didn't have an issue. The other LEDs also didn't have an issue, guys. I will catch you up in the next video.